Okay, folks, so this is the 2012 10C question. So just so that you can go through it and you can take your time doing it, the info from the question was 0.0096 grams. It had said it was the mass of the bracelet that had decreased, and what had been taken off essentially was the sulfur. So that is why we're going to divide 0.0096 by 32, which is the molar mass of sulfur, and it gives us 3 by 10 to the 4 moles of S. So at this point, we would be looking at our ratio and we would be looking to write our moles as ratio. But we can't do that because there is no single S in our equation. There is an S here and there is an S here, but there is no single S to do it. So then we have to go and look at it a different way. So we're going to look at the Ag2S and we're going to break that apart. So to do that, the breaking apart, there's 2 Ag and there's going to be 1 S in there. And we now know already that the 1 S is worth 3 by 10 to the minus 4. So we can apply a ratio to this equation. We can apply a ratio that goes 1 is to 2 is to 1. So therefore, because we know that the S is 3 by 10 to the 4 moles, the Ag2S must be 3 by 10 to the 4 moles as well. If you want to do the maths on this, by multiplying all of these moles by their molar mass, the total on the left-hand side in terms of grams will equal the total on the right-hand side of grams. They will all be the same because of the law of conservation of mass. So I've used this weird answer up here to be able to work out what the moles of a particular compound are. So now what I'm going to do is I'm going to use this number and I'm going to apply the ratio from up here and I'm going to rewrite it as moles. So my 3 is to 2 is to 6 is to 1 is now going to be 3 by 10 to the minus 4 is going to be 6 by 10 to the minus 4 is going to be 6 by 10 to the minus 4 is going to be 1 by 10 to the minus 4. And this now is the box and the piece of information that I need. So if I look at the question, the next question, part 3, says mass of aluminium used. So this is the one that I'm interested in. Now, if the part up here that we did, that getting this answer and not knowing what to do with it down here to rewrite our ratio, well, you know what, if you can't figure it out, why not just use that number? That particular year, it would have absolutely worked out, but if you can't do it, you just pick a number and you work with it all the way through to the end. So my mass of aluminium is going to be my mass triangle. So it is going to be the 6 by 10 to the minus 24 by my atomic mass of aluminium, which is 27. And when I do that, it works out at, this is 27. Oh, I think I put the wrong number in my own calculator. So gotta bear with me while in real time we work this out. So it is going to be does it work out as 5.4 by 10 to the minus 3 grams? So that part is done. Now, as you said, you can leave things out in terms of our question number up here in the top left. It was 10C. This part down here is essentially question 2 in the yellow box. This is the answer to question 3. And we can put IV down here, or if you're not sure how to label, you just go 1 to IV up here on the top left, and away you go. So in our last part of our question, it asks, what would the loss in mass of the tarnished bracelet have been if the alternative method removed all of the silver sulfide by polishing? So silver sulfide is the 1 by 10 to the minus, if we moved all of the silver sulfide. So this is the Ag2S if all of that was physically removed. So I need to find the loss in mass. So I need to go 3 by 10 to the minus 4 by the molar mass of silver sulfide. So that's going to be 108 by 2, and sulfur is 32. So when I do these together, I should be getting 248. So I'm multiplying this by 248, and when I do that, I get 7.44 by 10 to the minus 2 grams of Ag2S. So that is my final answer for part IV. Okay. So moral of this story is you found moles of something. It's not there by itself in an equation. Can you make the equation fall apart and apply a ratio? If you can't, then what you're needing to do is you just pick a number and use that number for your maths. Okay, so this is now tactics and gameplay, and you have this.